let's transition to the next thing. Now, we're going to talk about something that is something very unique, the remainder theorem. Okay, let's talk about the remainder theorem. All right, when it comes to the remainder theorem, okay, let's talk about it. The remainder theorem says if a polynomial f of x is divided by a factor x minus a, the remainder is found by doing f of a, i.e. f of a will give you the remainder. So what they're saying is that if you have a factor x minus a, okay, and then you end up in the polynomial given, you end up substituting f of a, okay. This function, if you substitute a into your polynomial, you end up getting the remainder if you divided this into your polynomial. Okay, let me give you a simple example so you understand what we're talking about. A simple example. Okay, it will make sense. Okay, example. e.g. okay, use the remainder theorem to find the remainder of, so use the remainder theorem to find the remainder of x to the power 3 minus 3x plus 4, 3x squared plus 4x minus 2. Okay, and over is divided by, so this thing is divided by x minus 1. So we're going to use the remainder theorem and then also prove this by long division, that if we're going to really find the same remainder. Okay, now so we'll first of all remember this, that our g of x, which is our divisor, is equal to x minus 1. Okay, so if we're going to do the remainder theorem, we need to find what we're going to substitute. Remember, when there it was x minus a, we substituted f of positive a. How did they arrive at positive a? It's simple. Equate the divisor that you're given to 0 and then make x the subject of formula. You end up getting x is equal to 1, or 0 plus 1 when you take the negative 1 that other side. Okay, then you end up getting x is equal to 1. So what you're going to substitute is x is equal to 1. So if you get your function, which is the polynomial given, is equal to x to the power 3 minus 3x squared plus 4x minus 2, and then you substitute 1, gives us 1 to the power 3 minus 3, we substitute 1 there, squared, plus 4, we substitute 1 there, minus 2. That gives us 1 minus 3 plus 4 minus 2. Okay, that's what we're getting. And then when we do the manipulation there, this will be 1 minus negative 3 is negative 2, plus 4 is positive 2, minus 2 is 0. That's what you end up getting. Okay, so what that is telling you is that the remainder, when you divide x minus 1 into that, is equal to 0. Okay, how you get it is by doing f of 1 to the function, and it will give you the remainder, which is 0. That's what the remainder theorem says. You don't have to do long division to find your remainder. That's what they're telling you. All you have to do is substitute the factor. Okay, that means equate your divisor to 0, then find the value of x. That value of x, substitute it into your polynomial, and then it will give you the remainder of that. If you use long division, you would find the same thing. Some of you may be like, I don't believe you. That's what I'm going to prove right now. Okay, let's try to prove it. So let's look at it from the long division standpoint. So we're going to write our division symbol like that. Okay, then we'll put our x minus 1 there and our dividend. Okay, minus 3x squared plus 4x minus 2. Okay, and so what we're going to do is we're going to say x into x to the power 3. I'm not doing anything else because I know these are already in descending order and they have every term. So x into x to the power 3 is x squared. Okay, x squared times x is x to the power 3. X squared times negative 1 is negative x squared minus. Okay, minus. Then x to the power 3 minus x to the power 3 gives us 0. Negative 3x squared minus x squared, that gives us negative 2x squared. We drop down 4x. Okay, x into negative 2x squared gives us negative 2x. Negative 2x times x, negative 2x squared. Negative 2x times negative 1 is positive 2x. We subtract the 2. Okay, subtract the 2. What we end up getting is here there's 0, and then 4x minus 2x minus positive 2x, it gives you 2x minus 2, and then we get x into x 2x is negative 2. Okay, negative 2 times x, it's wait a sec, x into 2x is actually positive 2, sorry. So 2 times x is 2x. Okay, 2 times negative 1 is minus 2. We subtract the 2, we end up getting 0. That's what I was talking about. If you divide this into that using long division, you get a remainder of 0. But the remainder theorem tells you that you don't have to do all that. All you have to do is equate your divisor to 0, and you find that x is equal to 1. Substitute that into your dividend, it will give you the remainder. That's what they're saying. Okay, maybe some of you will be like, no, it only worked for this one. So let's do another example, just to make sure we help the doubting Thomases, you know. So let's do that together and see how it will look like. Okay, so we want to find the remainder of the same guy. Sorry about that. It's the same function, but we're just going to change the divisor just to prove a point. Okay, and once you know this, it will just make a lot of sense. So let's use the divisor x plus 2. So using the remainder theorem, we know that g of x, which is our divisor, is equal to x plus 2. So we equate that to 0. X will be equal to 0 minus 2, which is equal to negative 2. So we'll substitute x minus 2. So our polynomial is f of x, x to the power 3 minus 2 minus 3x squared plus 4x minus 2. Okay, so we'll substitute negative 2 here, gives us negative 2 to the power 3 minus 3 negative 2 squared plus 4 times negative 2 minus 2. This gives us 2 to the power 3 is actually 8, and then when you raise something to the power 3 when it's negative, the answer is negative, so it's negative 8. And then 2 squared is positive 4. 4 times negative 3 is minus 12. And then here is 4 times negative 2 is minus 8 minus 2. Okay, so what you get here is negative 8, negative 12 is negative 20. Negative 20, negative 8, negative 28, negative 2 is negative 30. That's what you get as your remainder. You get a negative 30. Okay, so let's prove that by long division. Okay, let's prove that by long division. Okay, so we'll put our dividend here. Remember, it's already in order, so we don't have to manipulate anything. So 4x minus 2, and then here we put x plus 2. Okay, we'll put x plus 2 there. Alright, so it's x into x to the power 3. You get x to the power 2. X to the power 2 times x is x to the power 3. X to the power 2 times 2 is plus 2x squared minus. Okay, when you subtract the 2, you get a 0 there. Negative 3x squared minus 2x squared. Negative 3x squared minus 2x squared, you get negative 5x squared, and then plus 4x here. X into negative 5x squared gives us negative 5x. Negative 5x times x is negative 5x squared. Negative 5x times 2 is minus 10x. You subtract the 2. When you subtract the 2, what you end up getting is negative 5x squared minus 5x squared is 0. Negative 4 minus 10x. Okay, positive 4 minus 10x. You end up getting 14x minus 2. X into 14x, you get positive 14. 14 times x is 14x. Okay, 14 times 2, it's actually 28. Okay, plus 28. Okay, sorry about this. So we put a negative there. Okay, then we subtract the 2. Then we end up getting 14x minus 14x is 0. Negative 2 minus 28. Okay, that gives you negative 30. And that is your remainder. The exact same thing we found there. So the remainder theorem simply tells you that if you want to know the remainder of your polynomial, if you divide it with a particular divisor, you don't have to actually go through the trouble of long division. All you have to do is substitute the factor that you get, the value of x that you get when you equate your divisor to 0.